Good day everyone. Today I'm going to discuss a new lesson and it is all about the standard normal distribution. Before I proceed, let's have a short review of the previous lesson. Last time, we discussed about the normal distribution, and by definition, it is a continuous random variable whose values are distributed normally. Its graph is a bell-shaped curve, also known as the normal curve. Now, the graph of a normal distribution depends on the two values, the mean and the standard deviation. Now, let's have the standard normal distribution. A standard normal distribution is a special case of the normal distribution. This distribution occurs when a normal value or a normal random variable has a mean of 0 and a standard deviation of 1. So what's the difference between the two? When we say normal distribution, the mean value and the standard deviation could be expressed in any number or any form. 1,000, 2,000, 3,000, 150, 45, 11, 69, 5, any number will do. Whereas in standard normal distribution, the mean is always equals to 0 and the standard deviation is always equals to 1. Now, is it possible to convert a normal distribution into a standard normal distribution? The answer for that is yes. Standardizing normal distribution is the process of converting normal distribution into a standard normal distribution. Again, when we say standard normal distribution, the mean is always equals to 0 and the standard deviation is always equals to 1. Going back to the previous discussion about normal distribution, specifically the properties of the normal distribution, we discussed the area and the probability under the normal curve. We have 68.3%, which is within one standard deviation away from the mean. 95.4%, which is within two standard deviation away from the mean, and 99.7%, which is within three standard deviation away from the mean. We were able to use and solve for the probability under the normal curve using those three common probabilities simply because the values are in the standard score or in z-score. Now, what is a standard score? It is the equivalent value of a raw score expressed in terms of the mean and the standard deviation of the distribution. For us to solve for the correct z-score, we will follow the formula z is equals to x minus mu all over standard deviation, where z is the z-score or the equivalent value of the raw score, x is the given raw score, mean, and the standard deviation. Now, let's apply this formula in solving for the following problems. Let's have problem number 1. A random variable x has a mean of 4 and a standard deviation of 2. Find the corresponding z-score for x is equals to 7. So in problem number 1, we are tasked to solve for the z-score of the given raw score, which is 7. So identifying the given, we have x, which is the raw score, and that is 7. Mu, or mean, is 4, and the standard deviation is 2. So here are the steps in solving for the correct z-score of the given raw score. First is to copy the formula, which is z is equals to x minus mu all over the standard deviation. Next is to substitute all the given values to the formula. So we have z is equals to 7 minus 4 divided by our standard deviation, which is 2. And then by that, we can simplify the numerator and it will give us z is equals to 3 all over 2. Then simplifying 3 over 2, that will give you 1.5 as the value of the z-score. So therefore, the z-score of x equals to 7 is 1.5. Now, since we are done solving for the z-score, next is to plot that one in the normal curve. So in a standard normal distribution, the normal curve has a mean of 0 and the standard deviation is always equals to 1, so meaning to say that the interval in every number is 1. So what are we going to do is to locate the z value, which is 1.5 in the normal curve. So 1.5 is located in between 1 and 2. Next is to shade the portion under the normal curve that corresponds to the given z-score. So in shading the area under the normal curve, you will start at the center or the mean of the normal curve up to the given z-score. So our mean is 0, so we will start shading from 0 until 1.5. So the shaded portion under the normal curve is this portion. Let's have problem number 2. A random variable x has a mean of 1.3 and a standard deviation of 0.5. Find the corresponding z-score for x is equals to 1.85. So here are the given. X is equals to 1.85, mu is 1.3, and standard deviation is 0.5. Next is to solve for the z-score using the formula z is equals to x minus mu divided by the standard deviation. Substituting the values to the formula, so we have z is equals to 1.85 minus 1.3 divided by our standard deviation, which is 0.5. Next is to simplify the numerator. We have z is equals to 0.55 divided by 0.5. And that will give you 1.1 as the value of the z-score for x is equals to 1.85. So next is to plot our z-score 1.1 in the normal curve. So 1.1 is located somewhere here. So if we are going to shade the portion under the normal curve, it is in between 0 up to the given z-score, which is 1.1. So the shaded portion is this one. Let's have the last problem. Problem number 3. A random variable x has a mean of 5.2 and a standard deviation of 2. Find the corresponding z-score for x is equals to 3.72. We have the following given. Raw score is 3.72. Mean is 5.2 and standard deviation is 2. Using the same formula, we have z is equals to x minus mu all over the standard deviation, and substituting the values, we have z is equals to 3.72 minus 5.2 all over our standard deviation, which is 2. Simplifying the numerator, that will give us z is equals to negative 1.48 divided by 2, and the z-score is negative 0.74. So that's the z-score value, equivalent value of our x, which is 3.72. Next is to plot the given z-score in the normal curve. And since it is negative, then therefore, it is located to the right of the demarcation line. So negative 0.74 is somewhere here, close to negative 1. And if we will shade the portion under the normal curve, it is in between 0 and the given z-score, which is negative 0.74. That's it for the presentation for today. Thank you and prepare for the activity next meeting. May the odds be ever in your favor.